please come on stage. Clap for everyone. It's all yours. If you have the pointer is there. Yeah, the pointer. Yes, yeah, you point that side. The microphone, you can move. So that because we're going live, that's a camera for online. For online. So movement is also limited, so that we deal with the people online. Okay. Welcome. Okay.
Thank you. Good morning. Yes, so I'm excited to be part of this conference and to be able to make a presentation to you. And I thank the organizers for having invited me. So today I'm going to talk about use of machine learning to try and detect cyber anomalies. The specific cyber anomalies I'm going to be dealing with are credit card fraud, or we can say debit card fraud. These are important because it demonstrates that you can use AI to detect fraud and be able to react to it. This is based on work we've been doing, and so I've taken an extract of that, and I'm going to present that today so that you can see how this can be done and to show that it's possible, and possibly anyone who intends, especially for the programmers, you can see how you can use machine learning as part of your of the tools that you can apply in detecting and also dealing with cyber anomalies. So I'm going to get started, and the title of my presentation is implementation of machine learning tools for detecting cyber anomalies. And so this is what I'm going to talk about. I'll have a background, the objective, previous work, methodology, results, and way forward. And so we define online fraud, and you can see there the definition of online fraud. It's deception carried out with the objective of gaining financially. So online fraud, especially credit card debit fraud, though I'm going to be using the term credit card more frequently. I mean both credit and debit, because in Kenya we tend to use more debit card. Debit rather than credit card. We can see that the rise in this kind of fraud has come about because of growth in e-commerce, and even in Kenya we know e-commerce has grown a lot. A lot of organizations are providing their services online. Banks also are providing banking services online. People are able to access their accounts online. So you know, for a person to use your credit card, they require these three things. They require the account number, they require the card verification value, and the expiry date. All these can be found on your card, but people can obtain them through other ways, including if you've lost your card and you've not reported quickly enough, then that's a risk you're running. Social engineering, you can be tricked into diverging this information. In addition, the perpetrator can request a new card from your provider, and they can do this if they have your details. Yeah, If they have your details, they can make a call and request a new card, which will be sent to them, rather than, and they will pretend to be you. Also, credit card data can be stolen from merchants, for merchants who save credit card information. Although this is not a best practice, but if it's done, then that data can be stolen. There is also card skimming. Card skimming happens when hackers or malicious persons install malicious code on websites to just capture details that users are entering on that site. I'll put the presentation on my phone so that I don't have to look back there. Give me a second. And so we have some statistics there showing the extent of this vice. The European Central Bank has done this for Europe, but the data is a bit old. It's 2019, but you can see we are seeing there 1.87 billion euros was lost through fraud. Yeah? Then also 80% of this fraud was carried out through what is called card not present transactions, which means the owner of the card was not present, which means it was either online or through a stolen card. If we go to the US, in Europe, in US, we can see the reported fraud cases in 2021 was 390,000, and losses were amounting to 5.73 billion, again from card not present. So if you think of card not present, it means one doesn't have to swipe the card, yeah? Which means it's online, online transactions mostly. In Kenya, we couldn't get the data, but at least from the newspaper articles, we could see that it's still a problem. As you can see, we are noting there the report by KESAT, CC, Computer Incident Response Team. The growth in e-commerce has also resulted into e-skimming and credit card fraud. And then also business data, you can see there Safaricom and communications regulator face a class action suit over SIM swap fraud. Why is SIM swap important? Because SIM swap is the way that people are using these days to be able to access your online account, yeah, because they're able to get to intercept OTP messages that are sent, which are used to verify that is you is logging into the account. Yeah? So our objective, of course, was to test if we can use machine learning to detect fraud. We tested two algorithms, logistic regression and adder boosts. There is some previous work you can see there. The best performing algorithm was an artificial neural network, which you can see there is reported to have attained 99.71% in detecting fraud. But these results are a bit misleading because the others in this study never checked, never used metrics which we call the appropriate metrics when we say the data is imbalanced. When the data is imbalanced, we find that if you have two classes, one class can make 90% of the data set, the other class maybe makes 10% of the data set. For fraud, credit card fraud, we find most transactions are not fraud. Yeah? You can find cases where even 99% of the transactions are actually authentic, and only 1% are fraud. So we say that data is very imbalanced. So these people, they never used metrics which are appropriate for an imbalanced data set. So these results you are seeing there are a bit misleading, as we'll see later. There is also some other previous work that used these other algorithms, naive Bayes, k-nearest, and logistic regression. You can see there, the main thing you can see there is logistic regression does not perform very well. Yeah? You can see it's 0.54 accuracy, sensitivity 0.58. For those of you who have a background in machine learning, you know sensitivity means how many of the found cases are detected. So at 58%, it means if you have 100 found cases, only 58 are detected, and 42 go undetected. Yeah? That's what sensitivity means there. Yeah? So sensitivity is a good metric to really determine if the model you're using is actually detecting found or not. Yeah? So you also can decide if you want to live with the fact that the model is not detecting 42% of the cases. Yeah? We used a data set from the internet. This, of course, is not really the best thing, but we decided deliberately to use this data set so that to create sensitivity on the need to create local data sets, either through collaboration and working together so that we can curate data sets for using for local research and also for students to do projects. Yeah? You saw even in the area signs that even government is not reporting on the rate of credit found in Kenya. And so that's a problem we need to address, and that's one of the things we want to highlight. Yeah? That can't hide the information is not going to help in solving the problem. Yeah? So we can discuss that as we go on. Yeah? So this data set, as we've seen, is highly balanced with only 9% of the cases being found. But despite that, what it means is 9, or we can say 10% of transactions are fraud rate. You can see that's a very high number. It means 1 in 10 transactions are fraudulent. Yeah? So no one is really safe. Yeah? And there's really that need to protect ourselves. Again, 65% of these transactions are online. As you can see, the data set has 1 million records, and 65% of those are online. And so that's some of the attributes in the data set that were used for the learning purpose. There is the distance from home, how far from the home the credit card was used, distance from last transaction, ratio to median purchase price. Ratio to median purchase price means if your median purchase is, say, 10 shillings, now if one day you have a purchase of 1,000 shillings, then the ratio to median purchase price is that 1,000 divided by the 10, which is your median. So the ratio to median purchase price then would be 100, yeah, which would be very high. But you can see the average ratio to median purchase price is 1.8, which is approximately 2. It means that for most transactions, you never purchase goods more than 2 times what you usually buy normally. Yeah? So when you buy something, when you have a transaction which is 100 times what you usually buy, we are going to see, does that indicate that it's likely to be found or not? Yeah? Those are the kind of things you are going to be looking at. There are other statistics there you can see, like if it's a repeat retailer, you are going back to a retailer you've seen before. or you've vested before, you are using a chip, you are using a PIN, that is, you enter your PIN as you transact. It's an online order. Then we have the label, if the transaction is fraudulent or not. So in the normal machine learning, you have to do things like scaling. So we use standard scaling. You have to do train test split. You use 70-30%. You have to do cross-validation. We did 10-fold cross-validation. And so now I'll go to the results. First of all, let's look at distance from home. You can see there, if the distance from home, as it increases, the likelihood of fraud goes up. Yeah? So we are saying here, when distance from home is greater than 60, the likelihood of fraud is 25%. Yeah? When the distance is less than 60, the likelihood of fraud is 6.88%. The other one is distance from last transaction, and we are saying as the distance increases to 8 and above, the percentage of fraud goes up to 12.8. Distance is less than 8 is 8.16%. Yeah? So you can make your own conclusions about that. Of course, you might ask why we are using 60 and 8. 60 in distance from home and 8 in distance from last transaction. That's because that's the cutoff for what are called outliers. So for distance from home, the outliers start from 60 and above, and distance from last transactions, the outliers start from 8. Yeah? Then in the case of ratio to median purchase price, which I described using the 10 and 1,000 example, you can see it really goes up. If the ratio to median purchase price is greater than 5, the transaction is 65% likely to be fraudulent. And if it's less than 5, then the transaction is 4% likely to be fraudulent. Yeah? Repeat retailer, this one doesn't seem to have much of an effect. Yeah? With that, sorry. The person controlling the slides, okay. I think we are there. So there you can see this ratio to median purchase price. Yeah, which I was saying that when it's greater than 5, then the likelihood of fraud is 62%. When it's less than 5, is 4%, 4.5. Yeah? A repeat retailer, that one seems to have no effect. Whether it's a repeat retailer or not, there is no effect. There is little difference. Yeah? As you can see, in using chip, yes, using the chip, the difference is not much, but when you don't use a chip, the chip is, previously we used to have magnetic cans, but now they are cheap. Eh? In Kenya, I think we transitioned 100% to use of chip-based cans. As you can see, when a chip-based can is used, the probability of a fraudulent transaction reduces compared to when you don't use a chip-based card. And then use of PIN. Again, PIN, you know, PIN means you are present, most likely. Use of PIN, you can see when you use a PIN, the probability of fraud is very low, almost 0. Yeah, you can see there is 0.27%. I've seen some banks these days also provide online PINs. So you can see that's one way to reduce fraud. When the pin is not used, the likelihood is much higher. Online order, you can see when an order is online, the likelihood of fraud there goes up to 12%, 12.71. When the order is not online, is 1.34. Yeah? So you can see the difference that an online order is more likely to be fraudulent. Yeah? Which are the issues we are dealing with today here. Yeah? And so these are our results, these are our experiments. Once again, these are the metrics I was talking about. You can see the metrics are a bit different. We have accuracy, which was used in the previous study. You can see underboost. Underboost is a powerful algorithm being adopted these days. Is getting to 99.99% in terms of accuracy. But what's more important is the balanced accuracy, which takes into consideration both sets, the fraudulent and non-fraudulent. Yeah? And you can see it's still very high, 99.6. Recall is sensitivity, how well it's able to recognize fraud when it sees it. Yeah? So we are saying, if out of 100 fraud cases, underboost will recognize 99.9% of them. That means it will recognize like all of them. Yeah? And you can see for logistic regression, it's recognizing like 80% of them. So it will miss 20. You can see it's a big difference. Yeah? Although when you use the standard accuracy, they look like they are almost the same. But when you use the balanced accuracy, you can see the difference is very huge. In fact, recall is 60 for logistic regression, which means it will actually miss 40. Yeah? The specificity is about recognizing the non-fraud. You know, you also don't want to classify non-fraud as fraud. So the specificity, they are all doing very well. They are both not classifying non-fraud as fraud. Yeah? But then we have also other metrics there, precision and F1 score. But more importantly, our data set, remember we had a test set of 30%, which was 26,000 fraud cases, or 26,221. Logistic regression missed 10,000 of them, while underboost missed only 21. Yeah? So you can see the big difference. And then data that's not fraudulent, logistic regression classified almost 2,000 of them as fraudulent, while underboost, for the data that was not fraudulent, it classified 0 of them as fraudulent, which means it is called 100%. That's why you are seeing the 100% up there in precision. So, what's the way forward? We propose, of course, to test other algorithms, and as I said earlier, create local data sets so that we can use both for researchers and students. Then also try to apply machine learning to detect other anomalies, like denial of service attacks, intrusion attempts, phishing, swim swap, and so forth. Yeah, so that's the end of my presentation. MC, you can tell me if I'm receiving questions now or later.
Thank you, Dr. You will receive questions later. Please, let's clap for Dr. Now, when we say research, that is research. And this is data that is available. And